Excessive cycling of a climate-control compressor motor can stem from several factors. A tripped circuit breaker associated with the motor suggests potential issues beyond just air leaks. Let's delve into possible causes and troubleshooting steps. Firstly, excessive air leaks, as you mentioned, can indeed reduce the system's efficiency, forcing the compressor to work harder and cycle more frequently. Secondly, a dirty or clogged air filter restricts airflow, diminishing cooling efficiency and consequently increasing compressor cycling. Thirdly, a defective thermostat might not regulate the system accurately, leading to frequent on-off cycles. Fourthly, low refrigerant levels can reduce cooling capacity and increase compressor run times, contributing to cycling. Now, regarding the tripped circuit breaker, it's crucial to investigate these possibilities. 1. Overheating of the compressor due to excessive cycling can cause the thermal portion of the circuit breaker to trip. 2. Inrush currents, which are the high currents drawn by the motor during startup, can exceed the circuit breaker's capacity if it's not properly sized. If the breaker can't handle these inrush currents, it will trip. 3. While less likely since the motor is currently running, a short or ground fault in the motor windings could also cause the circuit breaker to trip due to excessive current draw. Here is a structured approach to troubleshooting. 1. Check for air leaks by carefully inspecting ductwork, registers, and other openings for any gaps or leaks. Seal any identified leaks to improve system efficiency. 2. Inspect the air filter. If it's dirty or clogged, replace it with a new one to ensure proper airflow. 3. Test the thermostat. Set it to a specific temperature and observe whether it cycles the system on and off correctly. If the thermostat is not functioning as expected, consider replacing it. 4. Check refrigerant levels. This requires a qualified heating, ventilation, and air conditioning technician who can accurately measure the refrigerant levels and determine if adjustments are necessary. Low refrigerant indicates a leak in the system that needs to be located and repaired. 5. Examine the circuit breaker itself. Verify that it is appropriately sized for the motor's running current and, more importantly, its starting current, also known as inrush current. The motor's nameplate should provide both of these current ratings. If the circuit breaker's amperage rating is lower than the motor's starting current requirement, it needs to be replaced with a breaker of the correct size. To properly size the circuit breaker, consult the National Electrical Code, specifically Article 430, which covers motor circuits. You'll need to determine the motor's full load current from tables 430.247, 430.240A, 430.249, and 430.250, based on the motor's horsepower, voltage, and phase. Then, refer to table 430.52 to determine the maximum allowable rating or setting for the circuit breaker. This table provides multipliers based on the type of circuit breaker and motor. For example, for a standard inverse time circuit breaker and a motor with a full load current of, say, 10 amps, the maximum allowable rating could be 250% of the full load current, resulting in a 25 amp breaker. However, always consult the NEC for the specific requirements based on your motor and local codes. Also, consider the ambient temperature where the circuit breaker is located. High ambient temperatures can affect the circuit breaker's tripping characteristics, potentially causing it to trip prematurely. If the ambient temperature is consistently high, you might need to upsize the circuit breaker slightly to compensate. It's crucial to use a circuit breaker that is specifically designed for motor applications. These breakers are designed to withstand the high inrush currents without tripping unnecessarily. Standard circuit breakers may not be suitable for motor circuits. When replacing the circuit breaker, ensure that you disconnect the power to the circuit at the main panel to prevent electrical shock. Use a properly insulated screwdriver and follow all safety precautions. If you are not comfortable working with electrical wiring, it's best to hire a qualified electrician. In addition to checking the circuit breaker size, also inspect the breaker for any signs of damage, such as cracks or discoloration. A damaged circuit breaker should be replaced immediately, regardless of its size. Furthermore, ensure that the circuit breaker is making good contact with the busbar in the electrical panel. Loose connections can cause arcing and overheating, which can lead to the breaker tripping. If you find any loose connections, tighten them carefully. After replacing the circuit breaker, monitor the motor's performance closely to see if the tripping issue is resolved. If the breaker continues to trip, it indicates that there is still an underlying problem that needs to be addressed. If all other factors check out, consider having the motor inspected by a qualified electrician to rule out any internal issues, such as winding faults or bearing problems. A motor with worn bearings or damaged windings can draw excessive current, causing the circuit breaker to trip. The electrician can perform tests to assess the motor's condition and identify any necessary repairs or replacements. It's also important to consider the type of motor being used. Some motors are more prone to inrush current issues than others. For example, high-efficiency motors often have higher inrush currents than standard motors. If you have recently replaced the motor with a different type, it could be contributing to the circuit breaker tripping. In such cases, you might need to use a soft starter or variable frequency drive to reduce the inrush current. A soft starter gradually increases the voltage applied to the motor during startup, which reduces the inrush current. A variable frequency drive controls both the voltage and frequency applied to the motor, providing even more control over the starting characteristics. These devices can be particularly useful for motors that start and stop frequently. Another factor to consider is the voltage being supplied to the motor. If the voltage is too low, the motor will draw more current to compensate, which can overload the circuit breaker. Check the voltage at the motor terminals with a voltmeter to ensure that it is within the specified range. Voltage drops can be caused by undersized wiring, loose connections, or overloaded circuits. If you find a significant voltage drop, you'll need to address the underlying issue to prevent the motor from drawing excessive current. Also, be aware of harmonic currents. Nonlinear loads such as electronic ballasts and variable frequency drives can generate harmonic currents that can overload the neutral conductor and cause circuit breakers to trip. If you suspect harmonic currents are a problem, you'll need to use a harmonic analyzer to measure the harmonic content of the current and implement mitigation measures, such as installing harmonic filters. Ensure the motor is properly grounded. A faulty ground connection can create a path for current to flow through unintended conductors, which can cause the circuit breaker to trip. Check the ground connection at the motor and at the electrical panel to ensure that it is secure and properly sized. The grounding conductor should be sized according to the NEC table 250.122 based on the size of the overcurrent protection device. Finally, consider the age of the circuit breaker. Circuit breakers can degrade over time, and their tripping characteristics can change. If the circuit breaker is old or has been tripped frequently, it might be more prone to nuisance tripping. In such cases, it's best to replace the circuit breaker with a new one of the same type and rating. Regular maintenance of the climate control system can help prevent excessive motor cycling and circuit breaker tripping. This includes regularly inspecting and cleaning the air filter, checking for air leaks, and ensuring that the system is properly charged with refrigerant. By addressing these issues proactively, you can extend the life of the motor and prevent costly repairs. Remember that working with electrical systems can be dangerous. If you are not comfortable performing any of these troubleshooting steps, it's best to hire a qualified electrician or heating, ventilation, and air conditioning technician. They have the knowledge and experience to diagnose and repair the problems safely and effectively. They can also ensure that the system is operating efficiently and safely. When troubleshooting electrical problems, always follow proper safety procedures, including disconnecting the power to the circuit before working on it and using appropriate personal protective equipment, such as insulated gloves and safety glasses. Never work on electrical equipment when it is wet or damp. If you are unsure about any aspect of the troubleshooting process, seek professional help. In summary, a climate control compressor motor cycling excessively and tripping the circuit breaker can be caused by a variety of factors, including air leaks, dirty air filters, defective thermostats, low refrigerant levels, overheating, inrush currents, and short circuits. By following a systematic troubleshooting approach and addressing the underlying issues, you can resolve the problem and ensure that the system operates efficiently and reliably. Always prioritize safety when working with electrical systems and seek professional help when needed. This comprehensive approach should help you identify and resolve the issue of the motor cycling excessively and tripping the circuit breaker. Remember to prioritize safety and consult with qualified professionals when necessary. Addressing the problem systematically and thoroughly will lead to a more efficient and reliable climate control system. Good luck with your troubleshooting.